Hey everyone again. I really love to see you guys joining our study jams to learn more and more advanced topics in Python. And I'm really happy that we already covered some basics of Python and some object-oriented programming concepts. So last time we already finished a whole course consisting of 4 weeks. And I'm sure, or I bet, it would be a little bit difficult to study this on your own because you may be reluctant to study and continue, but with these study jams, we were able to finish this course. And you might feel a little bit rusty in the skills of object-oriented programming. So I found some resources for you to recap, and maybe we can either spend time to code the game together, like using this hour, or you can just code on your own, and we will look at different projects for our future study jams or for future self-study. Let me know what options you prefer. And so the first, you can write in the chat or just unmute yourself. So the first thing I wanted to remind you of is what is class and what is the different type of attributes. So in here you can see a class counter, and does anybody know these all different kinds of code written here? Do you understand the meaning? Why is that defined here? What's the difference between different types of def? So it seems from the first side that they are all def, but actually they are different things. Do you already know about this? Can you find the difference? Yeah, so actually here we have functions, for example, increment, value, reset, and we also have a constructor here. Every time you see this underscore, init, underscore, it's going to be a constructor, which is initiated, so init, right? Initiated when you create an object of a class counter. And this constructor is usually used to define some attributes. For example, here we only have one attribute, so which means one description of a data, which is current variable. It equals to 0 right now, but using different methods, we can modify current value to +1 or reset it to 0 again. And so how can we understand the class and different things within the class? Imagine you have, maybe I have another source. Imagine you have, maybe not here. So you have, for example, a class machine and this one. So for example, some class, maybe there was a different class, like a ball. Yeah, like this one. For example, it's a machine, a car, and you can have different states of a car, like description, how many liters of gas, total kilometers run so far, or efficiency. This is like a description of your car, of your object, or a class, for example, like car. And you will have a behavior, which is actions defined by the definition of the methods, right? So just two things when you create a class. And when we have different description of our data, we can have public description. For example, here is the current, and usually Python attributes can be accessed outside the class. So we also have private, but this doesn't work for Python. To make it not accessible outside of the class, we need to make it restricted by private. So private is not used in Python, like this concept is not used. We should use double underscore to fix this issue, to prohibit using the attribute to, for example, modify it outside of a class. So as an example, we have here double underscore attribute. And if we want to access it, we need to use class. Sorry, we have this kind of alarm. So we need to access the attribute using the class call here. For example, if we create the class counter, if we use the double underscore here, then when I create the counter object, I will use either counter. I can use either counter, double underscore, and it will make a mistake, right? Because now in Python, we cannot use this, how it's called, maybe restricted or private attribute. So instead of single underscore, we can use double underscore to make it restricted, right? And here to use this attribute with the double underscore, we need to call counter itself, the class itself, and then underscore current. Okay, so what you need to know is that you can either leave the attribute public or make it private using the double underscore. Just a recap from the last weeks. Okay, then last time we covered different concepts like inheritance and maybe encapsulation and polymorphism, but I'm not sure if I explicitly explained you these two concepts. Here we have different example, a class sensor, which, as you already know, has the constructor and two methods, add data and clear data. We already know that these attributes are public because we don't have any underscores. And when we create the, when we define the constructor, we have here three arguments that we need to pass when we create the object, right? It's a name, location, and record date. Then imagine we created this class and we want to use it right now. So we define our first object, sensor1, and we call sensor class and provide three arguments, right? Then they used the NumPy random method, and they use the add data method of a class sensor, provided two arguments, which are range, it's a method of NumPy, and data. This is the defined variable or using the NumPy method. So we used this method, add the data, and we use another, so we used the attribute, we access the attribute of our class, or I should say the object, because object inherits, right, everything. We call sensor data, which is just, maybe it's a dictionary, right? So we can see here the output, the key, and is it a key? Yeah, I think it's a key and a value. So this is a pair, key value pair. Now we want to create another class using the method, using the concept of inheritance and extension of our method. So we create the class accelerometer, which inherits everything from the class sensor. Why we do this? We want to use everything we defined in the class sensor, but we wanted to create some unique information. For example, a new method called show type. And when we create the object of a class accelerometer, we will pass the same 3 arguments because the constructor is going to be used from the sensor, this one, okay? And when we created the object accelerometer, we will use the show type as we would use methods from the sensor. Now we can see here the output. So we created the object, we see the show type. Show type just prints the I am an accelerometer statement, this one. So we know that it works. Then another concept is with the inheritance is the method overriding. So here we extended the method, means like as English word says, we extended the possibilities for our class. We can also modify the action. So before we had here the show type, which just prints the statement, but now we will use the same method. So we define the same method, but in this class UCBA CC, some different kind of accelerometer, we will print that I am this type of accelerometer that was created in UC Berkeley, right? Am I correctly pronouncing this name? So this is why we do this. We want to have a model which works for any class of different sensors, but then we want to provide some unique properties for different kind of sensors. It's just the way to make your code a little bit more sophisticated, maybe cleaner and more understandable. And you can see here that we created the class sensor, which will be a superclass, and other class that inherit the superclass are subclasses, right? Here we have a different sensor, new sensor class, which inherits the information from the sensor class. And here we want to update the attributes. So let's just compare the attributes listed here. We have name, location, recorded brand. I think one more argument is added, which is brand. And how we use this? We will update the attributes. We add one more attribute to our class, which is brand, right? So this is just the example. How would we add a little bit more data to our subclasses? Is it clear what is called inheritance and what we do with the inheritance? Awesome, thank you. So we can either extend methods, we can override methods, right? Awesome. Another concept is encapsulation. I just want to a little bit maybe help you to start coding this game if you are still interested to have a demo day next week. So for example, we had the game with rules and different characters. An easy way to apply this knowledge would be, for example, to create a starter building which will have different kind of data written in the form of attributes, right? And different kind of actions you can do inside this building, like going forward and backward. I don't know, maybe open and lock the doors, maybe, or I don't know, do something in the room. It will be your starter code, which will be defined in the class building, for example. And then imagine you want to have some kind of quest and modify different rooms. For example, you will have two subclasses. One subclass will inherit everything from the building super class, but for example, one room will be a horror room where you will do some actions like frighten the gamer. Another room will be the treasure room where you do something in this room. For example, you can either add one more attribute, or you can extend which means add one more method to this room, or you can override the method, like modify the existing method in this room to serve your purpose. Another way you can apply this knowledge, you can create a character and modify character based on different roles. Another concept is encapsulation. So here is the sensor method. And I think here we have two more concepts like getter and setter. These are to work with the attributes. So we have here get version. So here's the version. By the way, we can already here see the name, which is public, attribute, location, private, and version. I think it's restricted version, restricted attribute. And we will have getter function, which will print us the statement, but how it will access the attribute within the class, it will use the get function, right? So we just call self, which is the object we created, and we call version. We have a setter function to modify the attribute within the class, and or you actually can do this outside the class because you will use the set version method. So as an example, here we created the sensor one, and we call the name, the location, the version. So here they explain that we cannot use the version, like this will be the arrow, because we already know the double underscore makes this attribute unavailable outside the class. And how to avoid this, we already saw this coming. So we use the get version method here, get version, to access the attribute outside the class. Okay, or you can even modify it and then access. Is it clear for you? Okay.
Yes, it is.
Awesome. So this is another, maybe I should just send you this link, because actually you can see here, there are many other concepts explained that we already covered with you, and some of them may be interested for further studies, like for example, complexity, maybe some problems you can solve using these concepts. There is also good chapters for debugging, and many more other concepts. And I feel like this is the source which you can access for free anytime. So please look at it. We used to study machine learning on Friday, but it's a little bit difficult now to keep up with the schedule. But if you're interested, let me know. I think I can surely restart our study jams on machine learning, where we can cover these later concepts. Awesome. Yeah. And another resource that I found is this one, which explains in simple language and with the sample code the things that I have already explained to you. I think with this we already covered. The one thing is this one. What's the difference between encapsulation and inheritance? So here is the class ball. We have different, one method, move the ball. And I hope you can understand what's going on here just by looking at the code. So we have different attributes, and which is just coordinates, right? X, Y, Z. And then to move the ball, we use self x plus equal x to update the position of the ball. Then we have a class player, which has the ball object created, and then a different function, which is throw the ball that we created already. So you can see here, we create a class where we create an object of a class ball. So this is the encapsulation, right? And the inheritance is a different thing. Inheritance is, for example, we have a vehicle and we have different kinds of like bikes, cars, buses, and trucks, which all falls to the same kind of class, but possesses different properties. For example, if you have bikes, you have some motorbikes, pedal bikes, but if you have cars, you might have even more different kind of objects that are not included in the bikes. So you want to make it a little bit more unique. In this case, you will use the concept of inheritance. So we have here a ball. I think they don't provide example for this type of diagram. Let's see. Maybe with the example with the ball. Oh, okay. So for example, we have a ball here, and you will have, what are the basics, like basic thing you can do with the ball? For example, you can define its color, its size, maybe purpose. And when it comes to purpose, this is where actually you can create a subclass. For example, basketball, ball, and football, for tennis, for I'm not sure what other type of ball you can use. So this is where you will use the concept of inheritance. It means that even though you have different balls for different kind of sport, you will definitely have the attribute, which is a size and a color. But maybe you will have a different kind of method because you will use this ball in a different way. And to make it even more easier, they suggest to think about the inheritance and encapsulation in the form of a question. For example, if is this a relationship has a or is a relationship, right? For example, the bicycle is a vehicle and it has a seat. We have here a ball. A beach ball is a ball, right? It's a type of a ball. So it's going to have the inheritance concept in it. I think this is a really nice example how to understand the concept correctly, the difference between encapsulation and inheritance. And another example is the polymorphism. So you can see here the example. Maybe you can try even code yourself to see the outcome. So please look at this source on your own. And I think we covered a little bit about modules. So maybe not a little bit, maybe enough for you to understand that once we create the classes, we use them by importing them, right? So we also use these modules when we worked with basic math problems. We imported math module, also random module. For example, when we work with the data, we can use NumPy, matplotlib library, and other modules that help us, that are already predefined. They have defined classes, attributes, and they are used freely to our needs. And we don't need to create another formula, another method, but we can surely extend the method of a predefined method in the NumPy, for example, library. Here, they show you different ways you can import methods. For example, from library, you import toys. The first thing we did, we created a turtle game, and we imported turtle from the turtle modules. If you are curious about this game, it's really simple game. You can look at the community page and find the first object-oriented programming study jam in the past events. And there you can find a recording from YouTube from our study jam, and just follow this YouTube video to create this game if you're interested. You can also import sub-modules or import the entire module by using the star sign, I should say. Okay. And this we didn't use before, and I'm not sure if I should cover it today. Maybe we can leave this for later. If you have any questions, I think this is a really nice time to ask. Otherwise, I want to introduce you different things we can do in the next study jams. And if you have any problems or just give me some feedback, would you like to proceed with demo day? Because I feel like maybe you are a little bit busy. You might feel like this demo day, this creation of a game is not useful, but actually when you're going to work with libraries, you actually use these concepts of object-oriented programming. And later, when you're gonna create some more complex programs, the good way to do this is to create classes where, or methods, for example, where your one function performs one task. So if you understand this, you will have just a better code. So I feel like for now, maybe this object-oriented programming feels like not useful, but as we're going to do some more complex projects, you will understand the meaning behind this, I feel like. So if you have no questions, then let's discuss different things that we can do in the next study jams. So I heard that Dimaral wanted to do some simulations or like modeling, maybe. I'm not sure exactly if it's a good idea to do simulations and modeling exactly for your research project, because for someone else it might be not that interesting. But I found this nice tutorial or maybe explanation how to do this with a sample code to just give you the idea that maybe this is something you actually already can do right now using the basic knowledge that we have acquired through these study jams. So this is one thing, the simulations, some modeling of different kind of phenomenon, depending on your research or I don't know, project idea. Another thing is we can start work with some data from internet, like scraping some web pages and build some models. I think it's related to some data science and machine learning, but we can certainly start doing this on Monday. We don't have to stay on the same page and just proceed with real projects where we can use Python. So this is the project that they use the data from some pages and created a modeling project. So I think we can do this. And also another thing, I think maybe this will be interesting for you. This is just for fun. You can create like an app using the Python and other concepts to transcribe the videos from YouTube. And two more projects that I can introduce to you is also the web scraping concepts and for creation of the chatbot. And one more thing is work with the Twitter data to get some information from the tweets. But all of these projects might require some additional knowledge from different tech fields. But I hope in these study jams, we can just gather together, and if we don't have something in our skills yet, we can just grasp during these study jams. So let me know if you like one of these projects, or you can suggest any type of projects that we should cover during this study jam. Or for example, would you like to just come to this study jam and do your self-study? And if you have any questions, we can discuss this together. Because why I ask, because I feel like there is no need for this study jam already, because you have enough introductory knowledge about Python, and you can just dive into creating some projects. Okay. So
I like all the projects that you suggested. So I think we can proceed slowly, one by one.
Mm-hmm.
Yeah.
I think we can do this. It would be nice if we, for example, would be aware of what type of project you do. Maybe not in details, but just update each other, maybe what methods you try and what type of maybe struggles you have. If you already overcame this, then how? And if you don't know the solution, maybe we can help by discussing or sharing some knowledge. I think in this way, if some of you take different projects ideas, for example, we will be more equipped with diverse skills. Maybe I'm not sure. If you want to work on your own, then maybe this Monday study sessions, we can continue to transform into machine learning or like some project creation study jam. Otherwise, I'm not sure how can I help you or how can I transform this study jam into more meaningful time. What do you think? So Sifiso said that web scraping is liked by introduction to computer science lectures and projects would be nice. So you mean you would like to start your own project?
I mean that maybe we can start by low-level programs just to accommodate our skills, and as we go along, I think it's easier to identify what you don't know. When you start building stuff with it, then you realize, oh, I don't know what this is. And then I think it's easier to now concentrate on that and teach us. If I say, I don't know what this is, then you teach that rather than just going through the curriculum.
Right.
I think I like your idea of projects because then I can identify what I don't know, because now I don't know what I don't know.
Yeah.
Yeah.
I agree with you. Thank you. Yeah, so the project that I have introduced is just really small number of projects in terms of the diversity and skills and level. So feel free to think about like maybe, I'm not sure, are you all like undergraduate or graduate students? Do you do some pet projects on your own? Do you have any kind of interests? Or if you have like research, maybe you have kind of goals and tasks that you want to accomplish, and maybe you think about it for a while, and you can write to our social media links or even on Gmail. For example, I want to try and create this project, and then we can follow along your process. How do you do this? Maybe I can share with you some tutorials. Even we can do study jams on this project particularly, for example. If you have ideas right now, it would be nice to know. Or do you want me to just pick some projects randomly?
I think for me, I don't mind if you pick. I think I learn better if maybe you choose and I have to try and learn what from what you picked from, because my mind might make me choose what's easier for me.
I see. What major are you? Computer science?
Yes, I'm computer science. I'm undergrad. I'm just wrapping up my semester as a sophomore, and I'm hoping to go into web development, maybe Python, Django, as for my backend, and also just learn some mobile development. But for my web development, my backend, I'd like to learn some Django.
Thank you very much for sharing. Okay. How about Dimaral and Ray?
Like, I'm also good with any project that you choose. But it would be good if we start with simulations. I don't know. I'm kind of interested in.
Yeah, the one thing is, so I have two things to discuss with you. So the first thing is, for example, you know that if, for example, we going to try, I don't know, some Python projects for web, like web scraping, get some information, I don't know, like there is also some projects that involved some knowledge of HTML and CSS. I think we can handle this, but there are many like sub projects, you know. For example, if you are interested in simulations, knowing that you are from chemistry major, I'm not sure if, for example, this type of project is going to be useful for you, but we of course can start doing this, and it's maybe in your interest to identify whether this is useful for you, or maybe you can Google a little bit and introduce a different kind of simulations that we should together study. And the second thing is, I personally really glad to have this kind of study jams where you already have some basic knowledge. So it's more about us studying together than me doing a workshop, you know, because I feel like the way I introduce you to the study jams is that I am an instructor and I'm trying to teach you, but I feel like we already maybe on the same page and we can just study together and teach each other by maybe sharing knowledge or asking some questions that you really don't understand or you want to know more deeply about. Okay. Yeah, so let's then, so if you want to move to the projects, then I recommend you to try and create the game, maybe finish the game that you started for the next week. So you already have a starter code. You just need to maybe add one more class or just show yourself that you understand what class means, attribute, different types of attributes, inheritance, polymorphism, maybe extension of the method, overriding of the method, and that's it. You don't have to do really big game or something. And then maybe next week I can prepare a small project that we can start together. Okay. If you don't have questions, that maybe that's it. So I wanted to just recall with you the concepts of OOP and introduce to some projects. And also, if you're interested in machine learning, let me know. Maybe we can restart our study jams on Friday at 5 and continue machine learning study jams. And that's it for today. Thank you, everyone.
Thank you.
Bye-bye. Awesome, Sipso. Thank you, thank you. Awesome.
I am.
Yep.
Like, is machine learning gonna be like from the start, like from the scratch, or we just continue?
Yeah, actually, we used to have machine learning study jams before, but I noticed that we have more people registered for Python and like up to 3 people registered for machine learning. So I thought maybe people are not interested. So we actually covered some basics, but we didn't get too far. So maybe it won't be a problem for you to just join from where we are now. Yeah.
Okay.
And
bye.
Yep.
Oh no, say goodbye.
Okay, bye-bye. Thank you.
Thank you. See
Bye-bye.
you.